Okay, let's do some problems using our empirical rule, which is the chart from the previous page in the notes. You can keep it handy for you, but just generally speaking, 68% within 1 standard deviation, 95% within 2, and 99.7% within 3 standard deviations. In the United States, men's heights have a mean of 69.1 inches and a standard deviation of 2.9. Distribution of men's height is bell-shaped. What percent of men have a height between 66.2 and 72? So we really need to find out how many standard deviations out on both sides this is. So how do we do that? Well, we find the difference. 69.1 minus 66.2. I would really put the 66.2 divided by our standard deviation of 2.9 is 1, which means 66.2 is technically 1 standard deviation below. 72 minus 69.1 over 2.9 is also 1. This is the reason that I would put this left. If the 66.2 is on the left, you get -1, and it lets you know that's 1 below and 1 above. And we know what percent are within 1 standard deviation on either side, 68%. What about 63.3 and 74.9? So we do 63.3 minus 69.1 over 2.9. It's -2. 74.9 minus 69.1 for 2.9 is 2. And between -2 and 2 standard deviations, that's 95%. What is that really saying? It says 95% of adult men are between the heights of 5'3" and 1/3 and 6'3". Which is probably true. Not a lot of people are shorter than 5'3" or taller than 6'3", but 1 out of 20, according to the data. Now, here's a different kind of question, though. It's what percent of men have a height above 72 inches? So we know from part A, 72 minus 69.1 over 2.9 is 1. So what is it really asking us? Let's look at our chart real quick. Here's 1 standard deviation. It's asking for everything above that. So that's, if you get a weird one where it's not exactly the number of standard deviations on both sides, just take your areas and add them. So that's the 13.5%, that 2.35%, and that 0.15%. When you add them all together, you get 16%. So that is always an option. You can always find all of the areas that work and add them together. It's totally viable. Now, one random thing that I probably won't test you over, but it could be on your homework, is the Chebyshev inequality. Let's see if the camera decides it's going to focus. Let's go off and on again. Oh, much better. I don't know what it was doing, but that's fine. For any data set or distribution, at least 1 minus 1 over k squared times 100% of the observations lie within k standard deviations of the mean, where k is any number greater than 1. Obviously, you can't have a fraction because the fraction squared gets smaller, and you can't have a negative percent of data lying within something. That is, at least 1 minus 1 over k squared percent as a times 100% of the data lie between the lower and upper bounds of that standard deviation. We can also use Chebyshev's inequality based on sample data. It doesn't need to be normal for this to be true, which is nice. The empirical rule works for things if they're bell-shaped. Chebyshev's inequality works for anything. We don't even care. We don't have to check. No, it doesn't have to be approximately normal or bell-shaped. So the average price of gas is $3.06 per gallon, maybe pre-corona, and the standard deviation is 6 cents. What's the minimum percent of gasoline stations that have prices within 3 standard deviations? So by saying within 3 standard deviations, that means k is 3. So all you do is plug in the formula, 1 minus 1 over 3 squared, and multiply it by 100 to get the percent. Now 3 squared is 9. 1 minus 1/9 times 100. That is 8/9 times 100, which should be 88.8888 repeating. Now, We'll round it. It doesn't say how many decimals to round it to. We'll just round to the nearest percent, roughly 89%. Now, what minimum percentage of gasoline stations had prices within 2.5 standard deviations? So same thing, just plugging in 2.5. Now 2.5 squared is 6.25. I don't expect you all to know that. This is 4/25. Also don't expect you to know that. Put it in your calculator. So that leaves 21/25. Because this is 25/25. Times 100. 100 divided by 25 is 4. 21 times 4 is 84%. Now here, it's going to do something different. What's the minimum percentage of gasoline stations that have prices between $2.94 and $3.18? So here we need to find the K. So to find the K, you hope that it's the same number on both sides, because that's the only way it works. So you should be able to use only one. So let's do 3.18 minus the average, 3.06, over the 6 cent. I think that's 12 cents divided by 6 cents, which is 2. So that means my K is 2. You can check the lower end just to be sure, but we're not going to. 1 minus 1 over 2 squared times 100. So 1 minus 1/4 is 3/4. 3/4 of 100, 75%. And that is Chebyshev's inequality, and that's the end of 3.2.